Let's get started. So the first step is when you're finding the inverse function, you pretend like the function's name is called y. So instead of saying f of x equals x minus 5, etc., you say y equals x minus 5 over 3x plus 2. So I'm going to write these steps off to the side. Step number 1 of finding an inverse function is to call the name of the function, change it to the letter y, like that. Second step of finding an inverse function is to switch the letter x to be called y and change the letter y to be called x. So this is the second step. So then you're going to go from that step and you're going to change the y to be an x. And you're going to say x equals, then you're going to change the x to be a y. So y minus 5 over 3y plus 2. The third step is you have to get y by itself. I'll just say get y alone, so it uses up one word instead of two words. So get y alone. To do that, you'll have to cross multiply the bottom of the fraction times the top of the left. So you're going to do x times 3y plus 2 equals y minus 5. Then you're going to distribute the x. So you get 3xy plus 2x equals y minus 5. And then you're going to have to get y alone, so put y on the left side and put anything that doesn't have y on the right side. So should I keep the 3xy where it is? Yes, because it has a y in it. And should I put the 2x where it is, or should I move it? It does not have a y in it, so I'm going to move the 2x to the opposite side of the equal sign. So that's going to make it become negative 2x. And then how about the y that is on the right side? That has a y in it. So I'm going to move the y on the right side to be on the left side. So it's going to change it to be a negative y. Because anytime you move something to the other side, it changes signs. Then how about the negative 5? Does that have a y in it? No. So leave it where it is on the right side. So leave the negative 5 where it is on the right side. So what you'll get is 3xy minus y equals negative 2x minus 5. And then it's going to work out the same exact way on the final, except the numbers will be slightly different. Does that make sense? Now you have to factor out the y because you have a y in the first part of that group and you have another y at the end of that group. And so if you take out a y, you'll be left with, actually, let me start writing this over here, I'm sorry. If you take out a y from the left side of it, then you'll still have 3x left. Okay, now remember in front of that negative y, that really means negative 1y, right? So negative y really means negative 1y. So if you factor out the y, you'll still have the negative 1 in front of it. So you'll actually have to leave that negative 1 there after you factor out the y. And that will still equal negative 2x minus 5. And then to get y by itself, what's the last step? So you have to, yes, you have to take this entire thing, which represents a big number. You have to divide that big number from being multiplied on the left side, and then divide it underneath the right side. So that big value goes divided underneath the right side. So your y by itself is equal to negative 2x take away 5 all over 3x take away 1. And then there's one final step to find the answer. The fourth step is change the new y value, change its name to be called f inverse of x. So the final step is to take that equation, y equals negative 2x minus 5 over 3x minus 1, and write f inverse of x equals negative 2x minus 5 over 3x minus 1. And that is your solution to the problem, is that formula. So that's probably going to be one of the hardest problems on the final, but now you'll be able to get a perfect score because now you know how to do it. How does that sound? Oh, and by the way, let me go ahead and take one more attendance real quick. This is incredible. I'm just so happy because I think, assuming that one person is excused, I think, then now we have perfect attendance which is amazing. Good job, everyone. Okay. So find the exact value of log 10 of 20 plus log 10 of 5. How do I do that? Well, remember when you have multiple logarithms, first check to see if they have the same base of logarithm. So are they both the same base, log base 10? So what you can do then is identify the factors of the logarithm. So the factors are 20 and 5. What you do is you multiply the factors together, 20 times 5. But you can only do that if you also put the coefficients that are in front of the logarithms. You have to put the coefficients in front of the logarithms. You have to put those on the powers of the logarithm. I mean, not the logarithms. The coefficients of the logarithms need to become powers of the factors. So what is the coefficient of the first logarithm? It's a 1, and that's a 1. So in order to put the 20 and 5 together, you have to put the 1 in front of the log onto the power of the 20. You have to put the 1 in front of the log 10 base 5. You have to put that on as a power of the 5. And the final, thankfully, is not as difficult as it is sometimes. So, but make sure that you remember, I'm going to draw an arrow to remind you, that number, whatever it is, has to go onto the power of it, like that. And then what happens if you bring the factors together and put the coefficients as powers on the factors? Then the two logarithms become 1. It merges the whole logarithm into a single logarithm, and it'll still have the same base that it started with. So you'll get one single log base 10 of 20 times 5. And 20 to the power of 1 times 5 to the power of 1. So what is 20 to the power of 1? And what is 5 to the power of 1? So it's still 20 and 5. And what is 20 times 5? 100. So the next step is to write log base 10 of 100. Now, you don't really have to use brackets if you don't want to. I'm just using them because sometimes if you have parentheses inside of parentheses, it's hard to see. But you could also just write a parentheses around the 100. So now comes the crucial question. If you got this far, you'd probably actually get at least half credit for it because you've done all the hard part. The last part is, how do you calculate a logarithm? It is equal to how much of a power it would take to raise the 10 to become 100. So what power of 10 would make the 10 become 100? A power of 2. So the answer is 2. How does that sound? Oh, and by the way, do you want to, well, I don't want to have to go back to my office, but I have a box full of calculators I bought on like a Black Friday deal or whatever for you. In case you don't have a calculator, you're allowed to use a scientific calculator on the final, but you cannot use your phones or any kind of computational type device like your Apple Watch or anything else like that. So no phones, no smart devices or anything, or no graphing calculators. But if you don't have a regular scientific calculator, then I brought like 8 of them or something like that. So you can borrow one during the final if you need one. If you have one, please bring it because there's obviously more than 8 of you. But I'll try to have your back if you need one. So number 24. How do we do number 24? So first, each side is like a big tangled up jumble, right? So we first have to like untangle it and combine all the like terms and stuff like that. So let's distribute this. Negative 3x. By the way, problems like this that seem simple, they're actually really important because I always want everybody to get a really good grade. So what if you have like a 70 or a 68 and I want to give you like a C, but then I have to like do an appeal or something. Somebody might look at your final and look at this easy problem. They might say, well, they got this problem wrong, so they really don't know college algebra, even if you got a lot of other things right. So make sure that you also especially do the easy problems right. So negative 3 times x is negative 3x. Negative 3 times negative 1 is positive 3. And then what happens to the 2x? It just comes down. And then equals comes down. 7 times x is 7x. What about 7 times negative 6? Negative 42. And always watch your signs. On the final, you'll always feel really nervous. At least on the first one, you'll probably feel more nervous. Hopefully by the second one and the third one, you won't feel quite as nervous because you'll like gain more confidence. So there we go. So here we have negative 3x plus 3 plus 2x equals 7x minus 42 minus 3. Now we still have to combine some terms together. So what is negative 3x plus 2x? What does that make? Negative x. What happens to the positive 3? It just stays the same. And then what happens to the 7x on the right side right now? At this point, nothing can happen to it. What about the negative 42 minus the 3? What does that make? Negative 45, right. Now, which is smaller, negative x or 7x? I mean, which is a littler thing? Not smaller, but littler. The negative x. So I'm going to get rid of the littler x because that saves you a little bit of work if you get rid of the littler one. So if I add plus x to get rid of the negative x, what's left on the left side?
8x.
On the right side, it's 8x. Yeah. And on the left side, what's left on the left side? 3, correct. And then what else is on the right side? Correct. So I'm left with that. Then what do I do next to get x more by itself?
Add the 45.
Add the 45, correct. And then what's 3 plus 45? 48. And then that cancels out. So 48 equals 8x. And what do I do to get x by itself? Divide it by 8. And you'll get, what is 48 divided by 8? So 6 equals x. There we go. Perfect. Amazing. There we go. So this next problem says given that negative 3 is a 0, find all the zeros. So what that means is when it says find all the zeros, it means solve the equation to when the equation equals 0. But that's not actually what you need to write down because we have now learned a method for doing that without even writing down 0 or anything like that. So do you want to know how to get 1 point of credit for this problem? Which is super easy out of 4 because they're all on the final, everything is worth 4 points each. So if you just write down x equals negative 3, because that's the first answer. So it says, given the negative 3 is a 0, that means negative 3 is one of the answers. So if you write that down, then that's like an easy 1 point out of 4. But then what do you do to get the rest of the 3 points out of 4? Because if you get 1 point out of 4 on every question on the final, guess what score that is? 25%, right? So you don't want to get just a 25%. So instead, you write down the number that is a 0 in a little box, kind of like on the left side of that little box. Then you write down the coefficients of the equation on the right side of that little box. So what's the coefficient of x to the 3rd power? And what's the coefficient of x to the 2nd power? Close. That was a trick question. It's 0. Because notice that there is no x squared in this problem. And that almost always happens on the final where they give you that little trick to make sure you're paying attention. So there's no x squared in the problem, so the coefficient of x squared is 0. Boom. What's the coefficient of x? Negative 14. And what's the coefficient of the number that doesn't have an x? 12. So 12. Then do you remember what to do next? When you're finding all the zeros of a function? You leave a blank space, like the Taylor Swift song. And then you bring down this 2. And you just write it down again. The first number always comes down without being changed because it's sort of like you can't really change your true identity in a way, even if the rest of yourself gets changed by the people around you or whatever. So negative 3 times 2 is what? Negative 6. And then what's 0 plus negative 6? And then what is negative 3 times negative 6? And then what is negative 14 plus 18? 4. And remember, what is 4 times negative 3? So let's remind ourselves what we're doing. We're always multiplying the number at the bottom of the table, multiplying that by the number in front, and then putting that up as the next number. Then we're adding those together. So we're multiplying and then adding. So our last step is to add those together. What is 12 plus negative 12? Yeah. So at the very end, it doesn't do this in the book, but I like to put a little box around the number at the end, just like the opposite direction as the box at the beginning. So this tells me that I have a new equation now, and the new equation is always 1 lower power than the original. So what is lower than x cubed? What's 1 power lower than x to the 3rd power? X to the 2nd. So this 2 right there represents not 2x to the third anymore. It represents 2x to the second. And this -6 represents -6x. And the 4 represents the number that doesn't have an x at all. And since the remainder is 0, that means that equation is equal to 0. So we've reduced the big equation to a little equation. And furthermore, I'll try to make the final a little bit easier than this, or I can't really make it be easier, but hopefully the final won't be quite as big as this. So do you see the 2 and the 6 and the 4? It just so happens in this final, this is actually what the final was, exactly what the final was in the previous spring, last spring, I think. So what do you divide by to get rid of the 2 and a 2 from all those different numbers? Divide by 2. So if you have an equation and everything is divisible by 2, this doesn't always happen, but if you do, it's a good idea to divide everything by 2 because then the problem will become twice as easy. So before you solve that equation, just divide it all by 2. But you can only do that if 2 divides into everything. So what do I get if I divide everything by 2? You always get x squared minus 3x plus 2 equals 0. Now, is that equation pretty easy? Yes, at least hopefully. I think it's pretty easy for you. So write parentheses down, and you have to factor it out. So what does x squared factor apart into? X times x, right? I wonder if there's a way to zoom in a little bit. Guess not. Did it zoom in or not? Did it stay the same? Guess it stayed the same. So then what sign do you put after the first x? If you've been doing the method that I'm teaching, which this is not the only method, but the way that I think is the easiest is to go ahead and put that sign down. And then what do you do next? Multiply this sign times this sign. So it is negative times positive. So that sign is also negative. And then you need to take this number in the front, which is a 1, times the number at the end. What is 1 times 2? 2. 1 times 2 equals 2. And you need to break that number 2 apart. The only numbers it breaks apart into is 1 and 2, right? And you need to put those numbers into these blank spaces so that it adds up to -3. So which combination of numbers should I put in those blank spaces? There's only one combination. So just, yep, -1 and -2. No, the negatives are already there because I did those ahead of time. So just put the 1 and the 2 in those boxes. But always make sure that it does add up to -3. So does that add up to -3 if you take -1 plus -2? Yes. So that means those factors are correct. And I still have to solve it. So how do I solve the equation x minus 1 times x minus 2 equals 0? Set them equal to 0. So 2x minus 1 equals 0. And then, hold on. And then do x minus 2 equals 0. So how do I solve those two equations? Add 2 to both sides. And you'll get x equals 2. Boom. Add 1 to both sides. And you'll get x equals 1. Presto. Didn't you know Presto is a gas station? So maybe I'm not allowed to say that anymore. Did you know that you're not supposed to say Super Bowl because it's like copyrighted or something like that? You're supposed to say the big game, which is sort of stupid. Anyway, so find the sum of this next problem. What does that mean? Well, so remember I explained that this is kind of like the journey of your life. How old are you when you get born? 0. How old are you at the end of the, okay, so you start from the journey, you're 0 years old, 1 year old, 2 years old, 3 years old at the end. And then this is just representing a 3-year-old journey. So when you're 0 years old, what does that formula equal? So I think I said this is like, imagine how much money you had. So plug in 0 for k into the formula 3 times k minus 3. So 3 times 0 minus 3. And then when you're 1 year old, you'd plug in, what would you plug in for k when you're 1? You plug in 1. When you're 2 years old, you'd plug in 2 for k. When you're 3 years old, you'd plug in 3 for k. So do you see how every year of your life, you have to use that formula, 3k minus 3. From whatever year of your life it says you begin at the bottom of the journey, up to whatever age you are when you're at the end of the journey. So the final usually begins at 0. Sometimes I've seen finals though that begin at like 1 or 2. So always remember, start your journey at the same number as what's at the bottom of that. And then always make sure that you end your journey with the number that is at the top of that. And then you have to find the total amount of all those results, because that's like the total of all your life's experience. So what is 3 times 0 minus 3? -3. And what is 3 times 1 minus 3? It'd be 3, take away 3 is 0. And what is 3 times 2 minus 3? That'd be 6, take away 3 is 3. What is 3 times 3 minus 3? Good job. And so then you have -3 plus 0 plus 3 plus 6. So what's the total of all this, all the results of this whole little problem? 6, exactly. Because -3 plus 3 cancels out, and then 6 is the only thing left. That's incredible. Now, are you ready for the next page? So these problems actually aren't part of the official final, but I'm going to put them on your final only. I'm going to sneakily add like an extra page to it. Not because I want to make it harder, because I'm worried about your grades and I don't want anybody not to pass. So study hard on it and make sure that you do these problems, because if you don't do them, then I can't give you the extra points on the final. So question 27, solve this problem. So first of all, this is something that we learned about very briefly, but we haven't done it for a while. So you have to think about how to break apart y to the 2/3 power. So I'm just going to tell you the answer right now. Y to the 1/3 times y to the 1/3. That's how to break apart y to the 2/3. Because y to the 1/3 times y to the 1/3 equals y to the 2/3. So that, once you know that trick, then the rest of the problem is easy. And you haven't done something like this in like several chapters. So I don't expect you to remember this right now. That's why I'm making it be a bonus question. And then what do you do with this sign? It's the same as what we did before. Just put that sign down in the first parentheses and then multiply these signs together. What is a negative times a positive? That's a negative. Wait a second. This problem looks kind of similar to me. Did we do this one already? Well, maybe not. Okay. So maybe it's just because this has both negative signs. I think that happened before. So what did we do next? We take a line that goes from the number in front of the problem, which is a 1, times the number at the end of the problem, which is 4. I went too far. So my rainbow looks more like a faucet or something now. So multiply the 1 times the 4, and what does that make? 1 times 4 equals 4. So you have to break that 4 apart. There's 2 ways of breaking it apart: 1 and 2, and 2 and 2. No, not 1 and 2, sorry. 1 times 4, or 2 times 2. So which pair is the right pair, 1 times 4 or 2 times 2? Yes, that's because when you put them in these blank spaces and you include the negatives as well with them, they have to add up to what value? They have to add up to the middle value, right? So the only way to get it to add up to the middle value is by putting 1 and 4 in, right? Because -1 plus -4 equals -5. Do you agree with that? So now it's still equal to 0. So so it's been factored right now. How do you solve it after it's equal to 0? Exactly. So both parentheses equal to 0. So I set that equal to 0 and that equal to 0. And then I move the -1 over, or add it over, in other words, to the other side. So if I add a 1 to the 0, what do I get on the right side? It would be a 1, right? So basically move the -1 from the left side to the right side, which makes it positive. How about if I move the -4 over to the right side of that equation? What happens to that? Turns into a +4. Now, here's the other thing that we haven't done this for a while, but if you want to take a power, move a power to the other side. If you have a power on one side around the whole side, it only works if it's around the whole entire side, which it is. you have to flip it over to put it on that side. So if this power moves to that side, then on the other side, it becomes a power of 3 over 1 instead of 1 over 3. And if you move this power to the other side, it also becomes a power of 3 over 1. And so this is a really hard question. I don't like saying that. I'm just lying. I don't like to lie. But what is 3 divided by 1? 3. So y equals 1 to the third power, what is 1 to the third power?
1.
So that means that y equals 1. Or y equals 4 to the, what is 3 over 1 again? 3. So what is 4 to the third power? 64. So y equals 1 and y equals 64. So that's all of that problem. Then this next question is another question from the chapter that we did about sequences. So do you remember that formula? So chapter 6 was about the that rule. Do you remember the name of that rule? Cramer's rule. Chapter 7 was about conic sections, and chapter 8 was about things like this. So you have to find the 101st term of this sequence. So which is the first term of that sequence? And what's the second term of that sequence? Now you could go a long, long way before you got to the 101st term. So is there any way of calculating what the 101st term is? Yes. So watch this, I'll show you. In order to get to the second term, you have to add onto the first term. Then what number do you have to add on to the first term? 3, right? And to get to the third term, what do you have to do? You have to add 3 again, right? You have to add 3 twice. And to get to the fourth term, what do you have to do? Add 3 times, right? So if you just say dot, 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 how many times do you think you'll have to add 3 to get to the 101st term? So the 101st term, you'd have to do what? You'd have to add 3 how many times? So let me write it like this. So to get to the second term, you have to add 3 onto the first number once. To get to the third term, you have to add 3 twice, right? So in other words, if I start with the first number and I add 3 once, I'll get to the second term, right? If I start from the first number and I add 3 twice, I'll get to the third term. So how many times do I have to add 3 to get to a certain term? It's always 1 less than that term is, right? So to get to the 101st term, I'd have to add 3 exactly 100 times. Does that make sense to you? So I have to add 3 times 100 to the first number. So what is the first number? 1. So therefore, I'm going to take the first number, just whatever it starts with, it could be anything, just start with that, and then add 3 100 times to that. So what is 1 plus 3 times 100? 301, because it's 300 plus 1. Boom. Wasn't that exciting? That's actually a pretty sneaky trick.
So that's 100 plus 3x to the 100?
So this is, well, we have to multiply before.
Okay.
So that's not an x, that's a time. I'm sorry. So, okay, so we're going back to just like basic arithmetic. So I'm sorry, this in algebra, this looks like it's 3x squared, but it's really just 3 times 2. So let me go back and change that times to a dot, because now that we're in algebra, arithmetic starts to look like x's instead. Okay, so there we go. How's that? So you'll do 3 times 1. Yeah, you have to do 3 times 1, add that to get to the second term, right? So you start from the first term. You always start from the first term, and then you add on. To get to the second term, you have to add 3 times 1. To get to the third term, you'd have to take the first term and add 3 times 2. So to get to the 101st term, you'd have to add 3 times 100. Does that make sense, that pattern? Do you like that strategy for making it easier? How many of you would have tried to count in your brains till you got to 101 numbers? Probably what I would have done as well. So, but now don't you think that makes it easy though? Because 3 times 100 is just 300 plus 1. Okay, now the next question, the top of a ladder. By the way, this actually sometimes is not a bonus question, so it's usually this they have something like this on the final, but this particular year they don't. So I thought maybe I could just add it on as a bonus. So let's draw a Little House on the Prairie. Have any of you read Little House on the Prairie? And it says the top of a ladder leans against a house at a height of 12 feet. So here's a little ladder, and it's leaning against a house at a height of 12 from there to there. So it's 12 feet up on the house, and it said the length of the ladder is 8 feet more than, oh no, I have a mistake in this. So the length of the ladder is 8 feet more than the distance from the house to the base of the ladder. So let me cross out that little space or whatever. There. Find the length of the ladder. So this almost doesn't sound like we have enough information to do it. But we actually do though, because watch. If I connect the bottom of the house to the bottom of the ladder, it makes a triangle, and we're assuming the house is straight, and then we're assuming the ground is flat. So therefore it's a right triangle, and we don't know how far it is away from the house because it doesn't say. So that's X. But it says that the length of the ladder is 8 feet more than the distance from the house to the base of the ladder. So here's the distance from the house to the base of the ladder. And how much farther is it? How much bigger is the length of the ladder compared to this distance right here? It's 8 more. It says the length of the ladder is 8 feet more than the distance from the house to the base of the ladder. So this would have to be X plus 8. Now, do you remember the Pythagorean theorem? Exactly. A squared plus B squared equals C squared. So to me, the shortest side, now the A and the B don't really matter, but I just kind of like to have the shortest one be A. So which of the three sides is the well, I guess you can't really know because I don't know what X is. So just using your intuition, which do you think is shorter, 12 or X? 12. I have no idea where. So I'll just put 12 is A. So I'll say 12 squared. And then what's B? X. And then what is C? C is always the hypotenuse. It's always the longest side. So there is no choice to what to put for C. It's always the diagonal side. So C is X plus 8. So 12 squared plus X squared equals X plus 8 squared. And I remember the first time I taught college algebra, I didn't even know this was going to be on the final. And I didn't even review it or anything. And so my students just felt like I had betrayed them because they didn't know how to do it or whatever on the final. So ever since then, I've always tried to teach them how, like you. So what is X plus 8 squared? It would be, so the way I taught you how to square a group of two things is first square the first. So square the X and you get X squared, right? And then next, instead of squaring anything, the trick is you move it down and just multiply it. So what is 2 times 8? 16. And what is 16 times X? 16X, right? So that's the trick for squaring a group of two things is, and then you square the last one like this. So what is 8 squared? 64. So most people, almost everybody in the world will get this one right, and they'll get this one right. Because it's obvious that X squared is X squared and 8 squared is 64. But most people forget that you have to bring down the 2 in the middle and do that times that. And whatever that turns out to be, which is 16, then you have to do that times that. So don't forget to do that step. And then what is 12 squared? And then X squared is just X squared. Now, the nice thing about the final is they do try to test to see your knowledge, but they try not to make you do too much extra work. So what would the next step be in this to try to subtract the X squared to get it to be on the same side, right? So watch what happens when I subtract the X squared. Guess what happens? Both of them just disappear. So that's amazing. 144 equals 16x plus 64. There we go. And then subtract 64 from both sides. So you get, what is 144 take away 64? 80. And then 80 equals 16x. And then divide by 16. This is why you might need a calculator, possibly. What is 80 divided by 16? 5. And now the awful thing about word problems is about half the time the answer to the equation is not the answer to the word problem. So 5 isn't the length of the letter. Why not? Because 5 is that distance. So how long is the ladder at x equals 5? The ladder is 8 feet longer. So the ladder is x plus 8. So you have to remember to go back and say the ladder is equal to x plus 8. So what is 5 plus 8? 13. Right. Exactly. Whoops, I had that off the page, my fault. Now, are you ready for the latest and the greatest problem of all? So this problem is also usually on the regular part of the final, but this semester it's not. So I just decided to make it be on the opponent's question. Because it's actually, it looks really hard, but it's one of my favorite kinds of problems because once you know it, it's super easy. So let's go ahead and do the graph of this question. Ready? So we'll make a graph. Boom. By the way, I am allowed to give you partial credit if you have something related to the correct solution on your answer. So I don't know if I get in trouble for this, but if you have a graph and that's all, technically that's related to the correct solution. So I might be able to get away with giving you a little bit of credit because I'm going to give you as much credit as I can. So, but first to actually do the graph, we have to identify the leading coefficient, which is this. Now, technically, there is also a coefficient in each one of the parentheses. Whatever is beside x is a coefficient or whatever. So, but there's one in that, one in that, and one in that. And what is 1 times anything? It's the same as it was before, right? So the leading coefficient is still going to be just only that -4. So what does the leading coefficient tell you about the polynomial's graph? It shows you what the right side of the graph does. So the right side of the graph, way over there is going to be, is it positive or negative? Negative. So I started drawing a positive. I don't know why, but it's negative on the very right side. And then we have to identify the x-intercept. So remember that fundamental theorem of algebra that says the x-intercepts are the opposites of the numbers that are within x, within each parentheses with x. So what's the opposite of 5? So -5. And what is the power of that parentheses? It's actually power of 1, I think, right? Unless I'm missing something. So the x plus 5 has the power of 1. That power is called how many times that answer happens. So that answer actually happens just once. And then look at the next parentheses. What is the x value? So the x-intercept from that parentheses? +3. And what power does it have on that parentheses? 1. 1. So you should write, the power should be called a multiplicity. So I just say m and then the power beside it. So it's 3 multiplicity 1. And then last but not least, what's the opposite of +1? And what's the multiplicity of that? 2, exactly. Now you might be scratching your heads and thinking, why in the world do we need to know multiplicities? Because each of those values is an x-intercept. So we have 3 x-intercepts. 1 x-intercept is a -5. And on the final, I'll just let you just draw 1 unit each for, in fact, you don't even really have to draw all those units. You can just label it with the number -5. That'd be fine with me. So there's the x-intercept at -5, and there's the x-intercept at 3. And then there's the x-intercept at -1. Okay, good. We have enough time. So what's the next x-intercept? It's at 3, right? And then the next one is a -1. However, though, now maybe it'll make sense. Because if all you know is the x-intercepts, then you cannot draw the graph. Because it's like flying in an airplane in the fog. If you have your eyes closed, you know which way to go. If you had a blindfold on and you couldn't touch or feel anything, how far do you think you could get before you run into a wall or something else? Probably not very far. So you don't know where to go when you're starting from the graph, and you get totally lost. So that's why the multiplicities are critical. If the multiplicity is odd, then the graph will change signs at that point. So is this an odd number or not? Yes, that's an odd number. That's an odd number. So at -5, since it has an odd multiplicity, it's going to change signs. So make sure you write a C down below it. And then a at 3, it also has an odd multiplicity. And then how about -1? Now, -1 is an odd number, but that doesn't matter. It only matters what the multiplicity is. So what's the multiplicity of -1? 2. And is 2 an even multiplicity or an odd multiplicity? It's even. So since this is even means equal signs on both sides, which means it does not change signs. So it's the same sign on both sides of that point. Now that's all you need to draw the picture. That's why, because you know it's negative on this side. So I drew that negative in the wrong place because I started to write positive. So it's negative on this side, and then it changes at this point to, so what's the opposite of negative? Positive. And then what's the same as positive? Positive again. And what's the opposite of positive? Negative. So here's what the graph does. It starts out negative on the right side, changes to be positive, stays the same and still positive, and then changes to be negative. So watch this. In one amazing magical moment, you can draw the whole graph now because it goes down on the right, crosses through here, becomes positive, and then at this point, there's always 2 options. You could dive below and make a downward loop, or you could dive above, make an upward loop. Which one is it? An upward loop. So there's an upward loop at that point. And then at this point, you could also make another upward jump, or it could go downwards and just go negative. Which one should it do? It should go negative. So it goes negative like that. And then now you're done with that problem. So then you'd have 16 extra credit points on the final. And did I say something else about how you could earn extra credit points last time? Did I say anything about visiting my office or anything like that?
No.
Okay, maybe that was my other class. So I said to my other class that if you visit my office hours and ask me some questions, like your hardest questions for like at least 10 to 15 minutes, I can give you 5 extra credit points on the final. So if you want even some more extra credit points on the final, you can find your hardest questions on homework or whatever, go to my office and ask those questions to me, and then you can get 5 more points. So good job, everyone. It's amazing to see you all.